My dear friends, I'm Louis Chen, a teacher candidate of the MAT program at Empire State College. Recently, in one of my newly planned assignments, I request my students to design their own electrochemical cells. Well, in this video, I'm going to show what a group of students may do to complete this project. If you look here, a typical electrochemical cell consists of copper and zinc solutions. The reduction takes place at the copper solutions. So copper is the cathode. Oxidation takes place in the zinc solution. Zinc is the anode. The solutions are connected by a short bridge, and electrons flow from zinc to copper to make the cell functional. The cells designed from the student must not involve with any chemical solutions. The students define what they need and they attain their own materials. They will develop the procedures and be ready on the day of the experiment. They can use textbooks, online materials, or internet for the research. I envision that they will either design a full battery or a simple hydrogen fuel cell. What I will do is to run a few experiments with a potato battery under different conditions. The materials I need are fresh potato, a copper electrode, copper wire or a penny is fine. A zinc electrode, a galvanized nail should do the job, some alligator clips, and a voltmeter or analog multimeter. I also need some cold and hot water, a few tablespoons of salt, and a temperature probe for setting up different conditions. So I will be back later with the experiments. Okay, I have already set up the first experiment. You can see here a slice of potato into two. A penny and a galvanized nail are inserted as much as I could into each potato. A penny on one potato is connected to the nail of the other to set up a series of two potato batteries. I also had the temperature probe on for about 5 minutes, and the temperature of the measurement in this indoor area is about 71 degrees Fahrenheit. I have connected the nail of the first potato and the penny of the second potato to the anode and cathode of this meter, and it read about 0.62 volt. 0.62 volt. I'm going to record this down and come back later for the second experiment. Okay, I'm now back with the second experiment. Now you can see here the setup is the same as the first experiment. The only difference is that the potato was submerged entirely in cold water for about 3 hours. Then I took it out, sliced into two pieces, and put the piece in this bowl with some water in it, about half full. So the temperature probe has been settled down after 5 minutes. It read about 71.2 degrees Fahrenheit. This measures the water. Now I have connected the nail, and the voltmeter read about 0.52 volt. Okay, 0.52 volt. So I'm going to record this down and come back later for the third experiment. See you later. Okay, now is the part 3 of the experiment. The setup is the same as the first two, but this time I add a lot of salt into the water, and the potato is submerged in the water for over 3 hours. Okay? And I'll also measure the temperature of the salt water is about 71 degrees Fahrenheit. Every time the temperature is the same. So everything is set up the same, and now I read the voltmeter. Amazingly, it goes down to 0.35 volt. 0.35 volt. And I'm going to record this down and set up the last part of the experiment. And see you guys later. Alright, my friend. I'm at the last part of the experiment, part 4. The setup here is exactly the same as the last 3 times. But this time the potato was submerged in hot water for about 3 hours. Hot waters. I add hot water on and off to maintain the temperature. And as you can read, the temperature is about 125 degrees Fahrenheit, dropping down. The setup is the same as last 3 times. Now let me read the volt. The volt is about 0.40 volt, okay, 0.40 volt. So same as last 3 times, I'm going to record it down and come up with the final review later. Okay, see you later. We are back for the last session of this video. Let's review our data. This is the temperature chart of the first experiment. The air temperature was 71 degrees Fahrenheit. The voltage was about 0.62 volt for a fresh potato not submerged in any water. This is the temperature chart for the second experiment after the potato was submerged in cold water for about 3 hours. The water temperature was about 71.3 degrees Fahrenheit. The voltage was 0.52 volt. The third temperature chart is the one for the potato submerged in cold salt water for about 3 hours. The temperature of the salt water was 70.9 degrees Fahrenheit. The voltage of the cell was down to 0.35 volt. And the last chart is for the potato submerged in hard water for about 3 hours. The temperatures range from 126 to 127 degrees Fahrenheit. The voltage when I measured was about 0.40 volt. Now we all know that an electrochemical cell converts chemical energy into electrical energy. In a potato battery, there is a transfer of electrons between the zinc-coated nail and the copper-coated penny. The potato conducts electricity. So keeping the zinc ions and the copper ions separate, electrons in the copper are forced to move and generate current. Although there may be some experimental errors, I will ask the student to answer these questions in addition to showing me the findings and writing the reports. So maybe you can address these questions too. Number 1, what should I do to make the experiment and results more accurate? Number 2, if the size of the electrodes increase, will the voltage increase? Number 3, will larger electrodes increase the amount of current the potato can produce? Number 4, if more than 2 pieces of potatoes were used, still more voltage will be produced? Also, how about the current? And number 5, the last one, regardless of what you saw on the result, what should happen to the potato and the voltage after the potato is submerged in cold water, cold salt water, and hot water for about 3 hours, and why? My friends, it has been my pleasure to show you this video. Hope you enjoy it and have a good day.